All right, so we're going to start now. Welcome everybody. Um, so how are we doing? And it's a new week, so we'll be looking at something new, although it's not like brand new. It's just new in terms of knowledge wise, but it's a continuation of your last class. So I came and then I met Chioma and I was asking her about the class last week and I was really impressed. Yeah, she said the class was very okay. She enjoyed it and all of that. So, can you please give a thumbs up to your teacher last week? I know he did a very good job. Yeah. All right. So, I'll be sharing my screen now. Let's see what we can do today. Right. So, once you give me some minutes, please. Let me be sure.
Hello. Hello. Let
Yes.
me try. Okay. A
Okay.
contract is a piece of code that runs on chain and that performs specific actions based on particular inputs.
Okay. Okay. Beautiful. Beautiful.
Okay, so a contract is a um, what is this called? This English I'm looking for. It's a self-executing piece of code
Okay.
that is stored on a blockchain.
Okay. Okay. Beautiful. So, any other person? All right. That's 100%. Yeah, you guys are all correct, right? So a contract, sorry. So just like you've all said, a contract is a piece of code that is self-executing. A contract is a piece of code that runs on the blockchain. So you are all correct. So let's start with Cairo program. So I believe last week you guys did Cairo programming, right? Language. So now the difference between Cairo programming language and a Cairo program is just simple. Now, whatsoever you build using the Cairo programming language is what is called a Cairo program. All right. So don't get it mixed up. The program is whatsoever you use in building, you use the code to build is what is referred to as a Cairo program. Yes. So a Cairo program is stateless. Now, when they say something is stateless, it simply means that it does not store information. It just carries out whatsoever function you want it to do without storing any information. So just know that a Cairo program in itself cannot store information. And it's not like Ethereum. I know some of you might be familiar with Ethereum and Solidity, where you know Solidity have um, a connection to the Ethereum blockchain. It can actually store data to the Ethereum blockchain. It can store transactions and other things. So that's one thing. Okay. So just know that. Now, that's where Starknet comes in. All right. That's why if you're having Starknet, you always have Cairo. Cairo in itself is stateless, it does not store. But Starknet now provides a kind of memory model in which you can store whatsoever thing you are using your Cairo for. You can store it on Starknet. And if need be, you can also retrieve it from Starknet, all using your Cairo program. But the Cairo program itself cannot store any information, it's stateless. All right. So now, unlike, for instance, now, this, I'm on my computer, right? And then I'm running this particular presentation on my computer. And if you look at the presentation was running on my browser. You understand? So now my computer is having a CPU, central processing unit, a real central processing unit, right? Now, Cairo, as it is, also have a central processing unit, but a central processing unit is a virtual central processing unit. It's not a real central processing unit like the one you have on your computer. Like for those that use Windows or normal PC, you have Intel or AMD, and then your ARM processors. So this Cairo now program, it runs on a virtual central processing unit, which is optimized for cryptographic proofs. All right. So that's the difference between every other program, like your JavaScript, your Python, and what again, your Rust, and any other programming language you could think of. So that's a distinguishing difference between Cairo programs and then programs that are being made by any other programming language. All right. So Cairo is built for zero knowledge proofs and validity proofs. This one you don't need to stress yourself about it. So now, what is now the advantage of Cairo? So what Cairo does is that it allows you to do some form of computation off chain. Now, when you say off chain and on chain, when something is on the blockchain, right, you can refer to that in as on chain. Once you hear somebody saying on chain, it simply means something that is already on the blockchain. It could be Bitcoin, it could be Ethereum, it could be Aptos, it could be Solana, right? Why, when you hear they say off chain, it simply means something that is not on the blockchain. So Cairo allows you to run some sort of computation off chain. For instance, now by the time we program in Cairo and run it, what we are doing is that we are doing all our computations on the off chain. You understand? And by off chain, you can use any other computer to do the computation. All right. So as such now, once you do the computation and all of that, what you just need to do is to compile all those computation as a proof and send it on chain. So all those computation you did on your computer now, the Cairo, we combine all of them, compress it as one single computation and send it on chain, that send it to the blockchain. Now, what the blockchain now need to do is just to verify what you have done on your computer, whether it is correct or not, right? So in a way, you are saving costs, because normally how things are being done is that you send everything to the blockchain. The blockchain will be the one to run the computations, and then after running the computations, it will verify it. So, but now you are taking off the computation from the blockchain and doing that on your own personal computer, whereas the verification is still done by the blockchain. So what you are doing is that you are reducing the overall cost. You are cutting down cost like extremely. So that's it. So now Kairos, just like I said, Cairo has an immutable memory model, right? So this immutable memory model simply means once you store a value in it, you can't change it, right? Unlike your JavaScript that you can, okay, let this be this, and then you come back and change it and say, okay, let X be 2. Then you come back and say, no, I don't want X to be 2. Okay, let X be 5. All right. So Cairo by default has a form of immutable memory model. That's once you say let X be equal to, let's say 3, you can come and say let X be equal to 5 again. It will throw an error. Now somebody will be asking that what's so special about it? After all, in JavaScript, you can use const and then you will not be able to change it. Now, the reason why by default is not as if there's still a way around it. I believe you did that last week, all right, where you can actually declare a variable as mute. That's, you want to make it mutable. So there's a way around it, but by default it's immutable. And why is it mutable? Is because since it's being used to scale, I wanted to say Bitcoin, sorry, since it's used to scale blockchain, you should know that if you are talking about the blockchain, one of the things that a blockchain is known for is being truthful, right? Is once a transaction is executed, it cannot be changed, right? So if Cairo is not immutable, if it is mutable, it means if any transaction that is being carried out by Cairo will definitely be able to change, and as such it will defeat the whole essence of blockchain. So just get that at the back of your mind. So if you look at this chart here, not really chart per se, but at least a diagram, you can see that when you are talking about Cairo, this relationship between Cairo and Starknet, right? Cairo as a program helps you for off-chain computation. We talked about this, where the whole computation, everything it needs to run, it runs it on your computer, right? And then what it does is that after running it on your computer, it now generates a proof. So that proof now is more like it combines the result of all the computation it has done and compress it as a file, right? And then that file, it will now send it to the blockchain for verification. So the blockchain will now verify that, okay, let's check, you claim that you have done all this transaction, right? We are not arguing, no, but we still need to confirm that whether this transaction you have done is true or not. So that's the only thing blockchain we need to do. So that is the relationship between Starknet and Cairo. So Cairo runs off-chain computation, generate a proof, send it to the blockchain. Blockchain verifies that proof, whether it is true or not. All right. So the whole essence of this is what is known as ZK knowledge. Zero ZK, that's yes, ZK, that's zero knowledge. That's what it simply means. All right. Where the blockchain don't need to know the computation. It just needs to get the proof that is being generated and then verify it. So that's why they call it zero knowledge. The blockchain don't have an idea of it. It just know that whatsoever is coming out from the computation, if it is correct, it will know. And if it is wrong, it will also know. So any question before we move further, please. So let's continue. Now, next, we'll be looking at Starknet contract, right? We started by looking at Cairo program. Now we are looking at Starknet contract. So what is Starknet contract, right? So it's a Starknet contract is specialized Cairo program designed to execute within Starknet OS. Of course, we all know what OS is, operating system, which itself is a Cairo-based program. Unlike general Cairo programs, which are stateless, Starknet contract have access to persistent storage, allowing them to. So all this plenty story, plenty story. What they are trying to say, you remember when we are talking about Cairo program, right? We say Cairo program is stateless. That's it doesn't have the ability to store anything it's doing. Once it's doing anything and it does that thing and it gives you the result, that's all. The result is lost. You can't get it back. But what Starknet does is that Starknet now takes advantage. A Starknet contract is also a Cairo program, but this time around is a Cairo program that is designed to be able to run on the Starknet operating system. Just like how if you are using a Windows, Windows is designed to run on your computer. If you are using a Linux, Linux is designed, or Ubuntu, or Kubuntu, or Fedora, all these packages are designed to run on your computer. All right. So now, but this time around, unlike the normal Cairo program that are stateless, they can't save to memory. Starknet in itself provide a means by which you can save whatsoever thing you are running with this Cairo program. You can save it to a particular storage. All right. You know, the reason why they're using storage, I know some of you might interchange storage and memories because majorly when you talk of memory, you're talking of RAM. Then when you talk of storage, you are talking of your normal, you understand. So allowing them to maintain and modify data across transaction. And why do they have to do this? They have to do this is because if you are running a transaction, you definitely need to save the transaction, right? Imagine somebody send you money and your bank cannot save the money they send you. It means the money will not reflect in your account. All right. So as such, they need to come up with something that will help them to persist memory. When you see they say persistent storage, access to persistent storage simply means access to the same storage. Not that access to one storage. When you do another, is another storage is giving you. No, it's giving you that same storage to make use of. All right. So now, capabilities of Starknet contracts. What are Starknet contracts capable of? So one is persistent storage. So I think we made mention of this one. And persistent storage simply means contracts can store and also access. You know, is one thing to be able to store, and is another thing to be able to access. That you're talking of your right. If to be able to store to a disk, you should be able to write to it. To be able to get back information from a disk, you should be able to read it. So that's what they are just trying to say. Starknet contract helps to persist storage. It helps you in such a way you can write or read. Then next is intercontract communication. Now, Starknet contracts can also be called by other contracts outside of Starknet, right? So you can use an Ethereum contract. You can connect it in such a way you call a Starknet contract right from the Ethereum contract. So that is another capability of Starknet contract. Then another one is L1 interoperability. So when they say interoperability, simply means it can work with a layer 1 externally. So for now, Starknet contracts are compatible with Ethereum. I think right now the team, the Starkware team and other people, they are working on the L1 interoperability with Bitcoin. That's in such a way Starknet will be compatible with Bitcoin. Yes. So take note of that. So just like I said, please, if you have any question, don't hesitate to. You can just unmute the mic and ask. All right. So what is a Starknet contract? So okay, we started here. So this is just the continuation, right? So a Starknet contract utilizes ZK stacks. So we talked about this ZK already, zero knowledge. So the stacks simply means scalable, transparent arguments of knowledge, right? To achieve scalability and security. So how does this whole uh, ZK stacks to achieve scalability and security, how does it works? So first of all, we have batch processing, right? So just like I said, I was talking about Cairo. So what Starknet does is that it takes thousands of transactions, right? It combines all of them, run them off chain, right? Everything in a single computation. So once it's done running them, the next thing is that it will generate a proof. We've talked about this one too. So this proof now that it generates, it will now send it to the blockchain for verification, whether the computation, whether the transaction were computed correctly or not. All right. So it will send it to the blockchain. In this case, it will send it to the Ethereum blockchain for verification. Now, Ethereum as a blockchain, instead of it to now run the transaction, what it will just do is that it will now take advantage of the already transaction that have been run and then save as a proof in a file. So the only thing Ethereum will do is just to verify all those transactions. And as a result of that, since Ethereum is not running any transaction, it's just verifying, there's a reduced cost and there's also increased speed. Because here, everything has been run here. You just need to verify. So there's speed in execution, and also there's a reduced cost. That's in terms of gas fee. I believe some of you must have heard of gas fee. So that's why if you are here and you have ever used Stack for any form of transaction, you find out that their gas fee is very, very small. And when I mean very, very small, it's even smaller than $0.01. That's how small it is. I think it's lesser than $0.1. Yeah, I'm sure it's less. Unlike Ethereum. I think Ethereum, there was one day I was trying to transfer $25, and then they were charging me gas fee of $6. They even collected more than 10%. Ethereum, they want to collect more than God. So you can imagine. But with this now, you have a very, very low gas fee and all of that, and then a very fast transaction. So at this point, is there any question before we continue? Wait, hope my network have not disconnect. This everybody just quiet like this.
We can hear you, sir. No question.
Are you sure?
Okay,
Yes, sir.
I think
So,
I have
because
a
me, I will ask my question. Oh. Okay. Continue. Go on.
okay. While running the off-chain computational transaction
Yes.
before generating the stack proof, how do you
Yes.
now come about? Because how do you verify that the whole transactions are being, like, maybe they are valid or something?
Good. That is the work of the blockchain.
No, you said once the proof is being generated on a blockchain, they will
Yes.
just verify the proof, not the transaction.
Yes. Good. Okay. Once it generates that proof, it's going to send the proof to the blockchain.
Yeah.
You understand? Yes. The
Yes.
Starknet itself, it will send all those proof to the blockchain. And then the blockchain, that's Ethereum in this case, but very soon, by the time they're able to scale Bitcoin, of course, including Bitcoin. So Ethereum will now be the one to verify. It will check whether the computation it has done, whether it is correct or not. And when it is not correct, it will reject it. When it is correct, it will accept it. Now, I know somebody might want to ask that, okay, how do we know that something is not correct? All right. So imagine you are processing a transaction, right? And then uh, you don't have, let's say you want to send money, stacks to somebody, and then the amount you are sending plus, you are not leaving any gas fee, like you are not leaving any stack for gas fee, you are just sending everything. In that case, your transaction will not be successful. All right. So even if it process that and send it, by the time it gets to the blockchain, the layer one blockchain, Ethereum, is going to reject it. Why? Because of course there's no, and I don't even think, if you don't ever have enough gas fee, I don't even think the transaction will go through from here. I don't even think the computation will even it will even go through. Talk more of generating a proof down to even verifying and things like that. So I don't know if that explains your question. If that answers your question.
Yeah, it's a bit clear now.
Okay. All right. So any other question before we continue? Okay. All right. So let's look at Starknet VM and persistent state. I think we have talked about persistent already, right? Where you can continually write and read, write to memory and read, write to storage instead, and then read from storage. So this, unlike a standard Cairo program, which is stateless, Starknet contracts run inside the Starknet VM, right? So I know somebody might be saying, what is VM? What is VM? Hey, I know if there's a Nigerian, I might even add D. It's a VDM, very dark man. It's just VM. Oh. So VM simply means virtual machine. All right. So, and when you're talking about a virtual machine, is a machine like your computer, but it's not a real hardware computer. It's more like a software that runs like a hardware. So they call it virtual machine. All right. They say which provides persistent state storage. So now this contract, that's, you're talking about the contract that now runs in this Starknet virtual machine. Always remember, Starknet contracts run inside Starknet virtual machine. All right. And now, what is this contract that's running inside the Starknet virtual machine? What is it capable of? One, is capable of storing variables. So it's a contract can define and update state variables that persist across function calls, and transactions. So if you see, anytime you see they are talking about state, I believe, okay, who can help us? How many states do we have? Like is it state of matter or call now? Hey God, I've forgotten physics. So like water, now how many states does water has? Somebody? Three. Good. So can somebody mention the three for me?
Liquid, solid,
Good.
and gaseous.
Good. So now you find out that when water is liquid, you say liquid, right? You call it water. But when it's ice, you say solid, ice, right? And then gaseous, you say vapor.
Yes.
Right? So each of these are states. So that is what they meant by state. Because variables can change. Let's say, okay, variable now is 1. It means that the state of that variable is 1. So you can decide to come and say, add 20 to this one. Now, if you're adding 20 to the existing state, it means the new state will now be 21. So it means the state of the variable is no longer 1, but is now 21. So you're having a new state. So state is just more like the existence of anything at that particular moment, the existence of anything at that particular moment. So take note of that. So the next one, communicate with other contracts. So we talked about this. We say a Starknet contract can be called by other contract outside of even the Starknet, right? Then finally, it sends and receives messages to or from layer 1. All right. Of course, we talked about the Starknet computing all the transactions, combining everything, sending them to the layer 1 for verification. All right. So all those ones now, by it is sending message to the layer 1 to verify. And once the layer 1 verify, it will send back a response. So there's constant communication between the Starknet contract and also the layer 1. All right. So that's why I see they are calling it cross-layer interaction, because there are two different layers. You're having Starknet contract running in the Starknet virtual machine on one end, and you're having Ethereum, Ethereum, which is running on the EVM. Are they even calling it safe? So, any question before we continue? We go to the next one. All
Yes,
right.
sir. Yes, sir. Yes, sir.
Okay, please go on.
So, please just explain what you mean by persistent state storage.
Good. Now, let me see. What is your name? Sorry.
I'm Prince. My name is Prince.
Prince. Beautiful. Okay, Prince. Let's say you gave me your flash drive. Like you bought a new flash drive, right?
Okay.
So since you bought a new flash drive, right? It means that
Yes.
at this point in time, the flash drive is empty.
Yes.
Good. Now, you now gave me the flash drive as your friend. You now say, guy, that movie way come on last week, way hot, beg, send all for me, make I watch this night. Now, I will collect your hard drive, plug it on my system, and send all the movies to you, to your hard drive. Now, your hard drive now is a persistent storage. Why is it a persistent storage? It's allowing me to be able to send something from my computer to the hard drive. And now, is a persistent state storage. Why is that? Why is it a persistent state storage? It's very simple. When you bought it, it was empty. Nothing was inside. Now you gave me to send movie. I sent movie and return it back to you. And now by the time you now try to access it again, that same storage that you bought that was empty, now by the time you open it, you now see videos inside. Now let's say tomorrow you watch all the movie, maybe you did all night and finished all the movie, and then tomorrow morning you come and say, guy, that movie I don't finish, I beg, help me delete that one where you send, put new ones for me. If I come back from work, I will watch them. So do you get what persistent state storage is? So it helps you to consistently be able to read and write, assess what is inside, replace it, and all of that. So any question? Prince is quiet too. Oh, Prince is still there.
Yes, I'm here. I'm here. Okay, so okay. From what I deduce from what you explain now is that persistent storage, it means that it's a kind of storage.
Yes.
A state where you can actually manipulate. It's a storage that you can actually manipulate. You understand? You can put things there and take it out, and it still remains the same.
Aha, beautiful. So that's just it. All right.
Okay.
Good.
Thank you.
All right. So let's continue. Now we are looking at Cairo as the native language of Starknet contract, because Cairo programming, the same Cairo programming language you learned last week, is the same Cairo programming that is being used to write Starknet contracts. All right. So say Cairo is the native programming language for writing Starknet smart contracts. Since Starknet is built using Cairo, contracts written in Cairo best leverage Starknet's scalability feature. Now, they are now asking the question, why is non-Cairo ideal for Starknet? Why is it that we can't just go and carry JavaScript or carry Java or carry Python and say, Cairo is too hard, give me Python, let me use Python to write. So why is it that they are using Cairo specifically? So one is because of Cairo is designed for stack proofs. I think we talked about stacks here, which is scalable, transparent argument of knowledge, right? That's one. So what does that mean? It means that Cairo ensures that smart contract executions can be efficiently proven using zero knowledge stacks. So zero knowledge, now I explained it to you, where the blockchain don't need to know about the computation that is being done. It just needs to look at the result of the computation and then verify it whether it is valid or not. All right. So next thing is that it is optimized for layer 2 scaling. All right. So just like what I explained before, that Cairo helps to combine many transactions, compute them, combine all of them, compress it into a particular file, and send it to the blockchain to verify. So that is what it means by optimize for layer 2 scaling. So it means that the Starknet now is now serving as the layer 2 to the Ethereum, which is a layer 1 blockchain. Then finally, performance and security. Now, just like I was explaining that by default, Cairo has an immutable memory model, right? By default. So it's take advantage of this immutable model, because when you are talking of blockchain, is something that is transparent. And when you say something is transparent, it means it's truthful. There's truth in it. So it's not something that you did a transaction, you bought goat for or ram for Salah, right? And then you are now coming back after you must have sent the money, collected the ram. You now come back and you are looking for a way to do in such a way the money you sent to the person will not go, so that you get both the ram and the money back. You understand? Like, it can't work that way with Cairo because of why the immutable memory model. Once you write to memory, right? It's not as if you cannot update it. You can update it, but there's what they call nouns, Nounce. I think you do that next week or next 2 weeks. I don't really know. Where it's keeping record of the changes that is occurring in the memory model of your blockchain applications. Well, let me just stop here so that I will not talk much. So any question from Starknet contracts? That's the section 2, we just finished. Is there anybody that has any question? Okay, oh, these people don't know me first. The kind of question I'll ask you, nobody's asking me question. No problem. No time we come. All right. So we'll be looking at Cairo, the third section now. We'll be looking at Cairo program versus Starknet contract, right? So let's look at what's some of the differences. Just like when you say Barcelona versus Liverpool, I don't know, or Barcelona versus Real Madrid. So now we'll be looking at the feature, because the differences is in the feature. You know, when you talk of feature, it's more like what something or what an object has, right? So we'll be looking at what each of them have and how they are unique to one another. Now, when you talk of entry point, okay, let somebody help us. When I say entry point of a programming language, what do I mean? Quickly. No, we don't have time again. Hmm?
It
Somebody
is
should
where
help.
the program starts when it is first run.
Beautiful. So when you talk of entry point, right, for every program, it is where the program starts the execution from. All right. So for Cairo program, it must always have a main function as the entry point. That's why if you look at the work you did last week, right, you find out that for everything you are writing, you must use main. For everything you are writing, you must use the main function, because without the main function, your Cairo program cannot run. Now, but for the Starknet contract, there's no main function. You have multiple functions, and each of those functions can serve as entry points. You can have 3, 4, 5 functions, and any of them can serve as the entry point. Yes. So next is the access to state. Of course, I've explained what state is. So anytime you hear state in blockchain, before the say state, you say Lagos, state, Abuja. It's not access to Abuja, access to Lagos. So, so just like I explained, so for Cairo program, it runs independently. Sorry, there's a spelling error here. It will be corrected. It's supposed to be DOS and does not have access to Starknet state. So I talked about this while I was explaining. Well, I said Cairo programs themselves are stateless. So they don't have access to state. They don't save anything. But Starknet now can actually read or write. When you see modify also combines both. It combines writing and updating as well. Yes. So it can read or modify Starknet state. Then, so you can simply say Cairo is stateless, while Starknet contract is stateful. So persistence. Somebody's raising up his hand. Please, you can speak.
Sorry, my network crashed. I didn't get what you said when you said access to states.
Okay, good. So access to state, just like I was saying, you know, when you talk about state, it means I've explained what state is here, how a program is at every point in time, the progress of a program at every point in time. So now for Cairo program, it does not have access to state. Anything you are doing, once you are done, that's all. If you want to redo that thing, it will start afresh. It's not storing anything anywhere. But for Starknet now, contract, it can save it to the Starknet state, right? So that's the difference between both of them. Cairo does not ever have state to begin with, but Starknet contract has a state. So you can read to that state, and you can also modify that state. Then persistence, just like I said, Cairo is stateless. There's no built-in memory anywhere. Whereas Starknet contract has a storage built inside of it. All right. Yeah, so it's stateful. Why Cairo program is stateless. So for execution, so just like we said when we started from the beginning, we say Cairo program, it runs in the Cairo virtual machine, and its work is for computation, right? Why the Starknet contract, it runs inside the Starknet virtual machine. We talked about that too, where we say the contract itself runs in the Starknet operating system. Of course, the Starknet operating system is running on the Starknet virtual machine, right? So interacting with the blockchain. So then next we have blockchain interaction. So for Cairo program itself cannot interact directly to the blockchain. It does not have that access. But for Starknet contract now, it has access to interact with a layer 1 blockchain. For now, it's Ethereum. But just like I said, the Starknet team are working on scaling Bitcoin. So very soon, the Starknet contract will also be able to interact with the Bitcoin layer 1. So next is deployment. So Cairo programs are not deployed anywhere. They are only used to run computation on your computer, on your machine. You can't deploy them. It's not like your JavaScript for our front-end sister, right? So it's not like JavaScript that after you must have do your React, you join one or two, you now move it, say, okay, time to deploy. Let's ship, let's deploy. You now deploy it. No. Cairo, you can't deploy it anywhere. It's meant to be used just on your computer. All right. So, but for Starknet contract now, once you write a Starknet contract, you can deploy it as a smart contract. All right. You can deploy it as a smart contract. Then next, definition and annotations. So Cairo program is defined as a standalone program without any special annotations. What they mean by annotations, right? We'll still get to that. Is when you are attaching a particular attribute to a program. Once we start programming, you see it experimentally. So you don't need to bug yourself about this for now. Yeah, we'll look at it practically. Whereas Starknet contract is defined within modules and must be annotated with this attribute to be recognized as a contract by the compiler. So finally, execution environment. So Cairo program is executed anywhere. I know some of you are using Windows. Some of you are using Linux, Ubuntu, Fedora. Some of you are using Mac. Some of you maybe you are even using a system that they have not made already. You're already in the future. So now, whatsoever system you are using, you can run a Cairo program on it. It does not matter the system. But for your smart contract, you can't run your smart contract on your computer. You can only deploy it from your computer. But that smart contract can only be run on the blockchain. So that is the difference. So any question before we move?
Okay. Sir.
Yes, please go. Okay, I'm listening.
Okay, I said apart from Ethereum and Bitcoin,
yes.
Are there any other layer 1? Huh?
Yes, plenty. You have Solana. Solana is a layer 1. You have Aptos. Aptos is a layer 1. You have Sui. Sui is a layer 1. You have Movement. Movement is a layer 1. You have Zion. Zion is a layer 1. So there are many layer 1s.
Okay, but Starknet is a layer 2.
Yes, Starknet is a layer 2. Yes, exactly. So any other question? So please permit me to point this out. This is actually a mistake. This first line. So it's a mistake from one end. So please forgive me. It's not supposed to be under a Cairo program because we want to look at how a Cairo program looks like and how a Starknet contract looks like. So can somebody just help me? Like, look at the two. What are the difference? Do you see any difference? If you see, then what are those differences? I need like 3 people, 4 people, 2 ladies, 2 guys. It's supposed to even be 3 ladies, because these days they say what a man can do, woman can do better. So I'm even expecting 3 ladies. So two guys and 2 ladies. Somebody just quickly, just one difference you can cite, and then I'm okay.
Hi, so in the Starknet
Okay, let me
contract,
start.
I can't see the main function main.
Okay.
I can't see it, but yeah, it's there in the Cairo program.
Beautiful. I love that. I love that. I wish we were in a classroom now that say let's clap. But if I say let's clap, some people clap now can off my mic. So next, another person, probably a boy before a girl again, then a boy. So what difference can you cite again? Even if the difference is just on the Starknet contract, is okay. It mustn't be on the Cairo program.
Okay. On the Starknet contract, I see an annotation, Starknet double those
Double column.
points contract.
Beautiful. Beautiful.
Yes.
Awesome. Awesome.
Okay.
So, okay.
Okay. You said this. This importation that you said that's in the Cairo program. We use
Yeah.
core colon Starknet stuff.
Yeah.
Normally, it's supposed to be only in the Starknet program here.
Yes.
It's not supposed to be in the Cairo. So the difference is that the Starknet it
Yeah.
uses this importation method, while the
Yeah.
Cairo doesn't need that.
Beautiful. Beautiful. I love that. This class they hot too. If I say myself go stop the teach, I go come join at the hot. So the last person, preferably a lady, please. So any lady can please go on.
I'm sorry.
Okay.
What the former guy said,
Yeah.
I don't know if it's correct.
Okay.
Because I think you can also import in Cairo programs.
Okay. Okay.
He
No.
said you cannot import in Cairo programs.
No, I think what he was saying is
No.
this particular
Okay.
contract state.
Yes.
That was what
That's what I
he
meant.
was
That's what I
talking
meant.
about.
Like this, this now the Starknet now in Cairo, you won't see this we import in Cairo normally. So that
Yeah.
what we import when we're writing in the dictionaries, we import there.
Yeah.
Where you see the dict, the 252 dict, but in Starknet you see the Starknet colon contract colon contract state, but you won't see that in the Cairo program.
Yes. Yes. That's good.
That's what I meant.
Yeah. I understood. No issue. No issue. Thank you. So the last woman standing, please, sharp. After now they brag. Say what a man can do better. So Mona represent sharp. Okay, no ladies going. So please, a guy can help us out. Now I mean my network don't cease. Okay.
Okay. On the contract side, you have several entry points.
Okay. Nice. Thank you. So hope we are getting it like the rest of us. Like hope is clear. Right? Okay. So let's look at the okay, section 3. Why is it looking like we did section 3 before? Okay, it's supposed to be section 2. Mona no verse. It will be corrected. So the third section, I will be looking at contract class, right? So now, what is a contract class? So a contract class is a definition of a contract. So it's just like, I know some of us are coming from different diverse programming backgrounds. Some are coming from Python, some from Java. So if you're coming from Python, you're coming from Java, even from JavaScript, yes, in a way, you must have done objects. Is it, what did they even call it? Is it OOB or OBB self? Why they forget this thing? You must have done object-oriented programming, right? OOP, object-oriented programming. So is this contract class is synonymous to object-oriented programming in your normal conventional programming language. But in this smart contract now is referred to as a contract class, not just classes and objects, but a contract class. All right. So you say it contains Cairo bytecode, entry point names, and everything that defines its semantics. So you say each class is uniquely identified by a class hash. Now, a class hash refers to the unique identifier assigned to a contract class in Starknet. When a class is declared, the network registers it and assigns a unique hash known as the class hash. A contract class. So all this story you are seeing, what it simply means is if you carry contract now, a contract class, and you move it, you deploy it, right? Because before you even deploy, you have to declare first. So after declaration, then deployment. I think you do that next week. That's what you'll be doing next week. You learn how to declare and deploy. So once you declare a class, the network, that's the Bitcoin network, will take note of it and then gives the class hash, the class, a unique identifier. For those that into programming must have done, maybe if you are working with databases, you see what they call ID, identifier, where for every ID is unique. Then for those that uses things like is it UUID4? You see one long string of text. Is it a 32-bit length? I can't even remember anymore, or 16-bit length. So that's what a class hash is. But now this class hash, well, let me know. This hash is, there's a way it's been gotten, algorithm, like with an algorithm, in such a way is impossible for for two transactions to have the same hash. Is done mathematically. You can go and search for SHA 256. Go and search about it. SHA is an assignment. I'll ask you in the next class. SHA 256. That's one of the algorithm. In fact, it's the measure algorithm that is being used for hashing in the crypto Bitcoin blockchain space. Yes. So when you SHA 256, anything you SHA 256 two times, it gives you an hash. So I'll stop there. Go and do the remaining yourself. So a contract class in Cairo defines the semantics of a contract, including one, the names of entry points. Pay attention to this because I'll ask a question after this immediately. 2, the addresses of storage variables. And then 3, the events that can be emitted. Now, looking at what we have here, can we say this is a contract class? If yes, why? If no, why? So I need 2 people. Please, very fast.
Yes.
Okay, why?
Okay, so can you go back to that other slide where you listed those 3 things?
Okay.
The addresses of storage variables, the events that can be emitted. So you can go back, please. I don't know, but I think the events that can be emitted here are like functions to get balance,
okay,
to increase balance. Then about the storage,
yes,
maybe the struct there. I'm not sure. Yeah.
Okay. All right. That's awesome. So the next person, we say no. We have one for yes. So,
hello.
Yes.
Let me answer.
Okay.
So yes, this is a contract class. Although one is missing, the event. But the storage address is there. That is that storage struct and the entry point, those functions there.
Beautiful. So thank you so much. So you're actually correct. The only thing missing is actually the event, right? The event are supposed to be there. So the event is like it's just like notification on your phone. You hear your phone do bang 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 bang. It's you can check WhatsApp message, you send me message. So that's what events are, and they help you know more like help you understand what is going on and all of that. Most especially if you are dealing with functions that are view functions, right? I don't really know. We'll still come to that. Please forgive
Okay,
me.
so sorry. Those are like the entry points then, those functions there.
Yes, all the functions here and the entry points. You're right.
Okay.
Yes. Then just like you say, the struct here is actually the storage. All right. Thank you. So now let's look at what is a contract class. Right. I believe from the question I even asked, we shouldn't be looking at this slide. So I'll just pass it. If you can go and look for it. Another section 3. Sorry, forgive me to be corrected. So we have looked at contract class, right? We just finished contract class. So let's look at contract instance. When they say instance, contract instance, what does it mean? All right. So I believe those that are into programming, you have class instance, right? Or object instance, as the case may be. I don't know. So a contract instance is a deployed version of a contract class on the Starknet blockchain. While a contract class defines the logic and structure of a contract instance represents a live stateful version of that contract that can be interacted with. So from this definition, can somebody help us? What is the difference between, is there any difference between a contract class and a contract instance? If your answer is yes, what is the difference? So quickly, somebody. Go on, like I can't, I can't see.
A contract class, we can say that it is a blueprint, and a contract instance is the materialization of that blueprint into something real.
Awesome. So who can, is there any lady that wants to give it a shot? Okay, that's good. Yes, so that's correct. So your contract class is when you just write code like this. Make I write, make them know say I come from GIDA Bootcamp. Make I write this contract, make them know say na badass programmer be. So what you just have is just a class, right? A contract class. That's just what you have here written.
I think somebody's hand is up.
Okay, please just unmute your mic and speak. I can't see what's going on.
Sorry, I raised it before and I forgot to bring it down. Sorry.
Okay, no problem. So when you now pick this, right, which is this contract class, and you now deploy it to the blockchain, deploying it to the blockchain now is now stored somewhere. It now has memory. It has ability to interact with the blockchain and all of that. So in that case, it has now become a contract instance. So now let's look at some of the features of a contract instance, right? So it corresponds to a contract class. Are you seeing it? But has its own unique address. That's unique address on the blockchain, of course. Then next, it has its own storage that persists on the blockchain. Why? Because it's now on the blockchain. So anything you are doing, you are playing around with it and all of that, it persists on the blockchain. That is stores things directly to the blockchain and as well as retrieve things when needed directly from the blockchain. So another is that it can be called by transaction or other contracts. So other transactions that are related to it can be called, as well as other contracts also can interact with it because it's now on the blockchain. Then lastly, it has a nonce, and this is what I was trying to explain, which increments with each transaction sent from the contract. So this nonce now is a value that's attached to every contract instance. So for every change you make on the contract, there's always an incremental value. Like this nonce will always increment, it will increase. So simply showing the number of times that this particular contract instance have interacted or number of interaction it has undergone, right from the point where it was deployed up to that particular time. Yes. So are there any questions before we move to the next one? Or any contribution? You can contribute to, you must not always be asking questions. Can contribute. Anybody? Okay. So let's go on. So we have functions and interface in Starknet, right? So what are interfaces in Starknet contract? So in Starknet, interfaces define a contract externally callable functions without implementing their logic. They act as blueprints, allowing contract to specify which functions should be exposed to the outside world. So now, if you are coming from programming language like C, like Java, although I don't know much of Java, but I think Java implements the same thing, like C++. No, there's what they call function declaration. And there's what they call function, somebody should help me. Function declaration and function, I've forgotten the other.
Initialization.
Good, God bless you.
Function expression.
Right? Good. Function expression, exactly. So you see that function declaration is a situation where you just give the name of the function, of course, the function keyword, the name of the function, the function parameter. That is in a situation where the function has parameters, and then the function return. That's in a situation where the function is returning something. That's just what you give. But when you now come to the function expression, that's where you not only give the function name, parameter, and return type, but you also implement the logic or implement whatsoever activity that function is going to be doing. All right. So now interfaces is just like your function declaration. It's like you are saying, okay, for this smart contract I'm writing, these are all the functions I'm going to be using. You give the name, you give the parameter, and give the return type. So anybody that is coming, once he sees your interfaces, he will have an idea that, oh, this person actually has 5 different functions he's trying to implement in this contract. All right. So that's what they mean by interfaces in smart contract. So let's look at some of the key characteristics of interfaces in Starknet. So one, they say defined using a threat and annotated with this. We'll still look at that when we start programming. Then second, we say contain only function signatures. So if you hear function signatures, it's simply when you have just your function keyword, function name, function parameter, and then function return type, if there is any. So those are called function signatures. Then next, ensures consistency across contracts, implementing them. Now, once we start programming, we'll look at how this ensures consistency. Now, once you define a function in the interface, if you start implementing the function and you did not implement even one of the, let's say you have 10 functions in your interface and you implemented just 9 of them, your program will be throwing you error. Now, why will it be throwing you error? Because it's trying to tell you that, this your program you are writing is inconsistent. For interface, you are giving me 10. Now you're implementing and I'm seeing 9. Right? Just like you go to buy something and then you pay for 10, they give you 9. Be like, okay, how much I give you? You say, you give me 10,000. You say, okay, how much did they say 1? You say 1,000. So see how many you give me? 9. Okay, sorry. See the other one. So that's one of the uses of this interface. So the last one is it allows other contracts to call these functions, enabling modularity and interoperability. Right? So this modularity is more like it helps you to, instead of you implementing a particular function twice, let's say you have 5 files and you need to implement one particular function in 4 of the files. You don't need to go and be implementing the same function in 4 different files. You just need to implement it on one file, right? And then you now call it on the other. So that's what interface helps you to do, to maintain that modularity and also interoperability. All right. So any question on interfaces before we go on?
Yes, sir. Yes, sir.
Okay, please go on.
Sir, please, the bullet points 2 and 3.
Yes.
My network had some glitches when you were explaining that part. So I before I could work on it, you were at the last bullet point. That is allowed other contract. So contain only functions measurable. Can you explain that and ensure consistency across contracts?
Okay.
Them?
Okay.
Just
So function signatures, just like I said, is just your function keyword. And anytime you hear me say function keyword, is because different programming have different way they do. Like for Python, you have def as their function keyword. For Rust, you have fn. I think same thing with Cairo is also fn. For Go is func, func. I don't know. It seems that's it. Then for which one again, Seth? I forgot him. Monoverse. For JavaScript, we have function, normal function, right? So why consistency is just like I explained. If you put any function in your interface, when you come to implementing those functions, you have to implement all the functions that is in your interface, or else your smart contract will keep throwing you an error. It will not even compile. It will not agree to compile. All right. So it's more like keeping you in check. That Oga, here you put 5 function. Here you are implementing 4. The other one, who you leave on for? So something like that. All right. So is there any question? Okay. So now this is actually an example of interface, a function interface in your smart contract. So you can see this thread, which is the Starknet interface, trying to tell you that this is actually an interface. And then you have your threads keyword, and then you have I example contract. Now, this I is not really necessary, but it's advisable. Why? This I will always signify an interface. Then this name is based on any name you are calling your contract. So in this case, our contract is example contract. So we attach I to show that it's an interface. And then you can see that we only have function signatures. That's no function bodies at all. We're only having function signatures, which is your function keyword, your function name, your parameter. You see this one, it means what this one simply means that this function is not returning anything. So that's why I see it does not have the return type. Why this one? Also, you have your function keyword, your function name, then your return type. Of course, you can see that this function is not taking in any parameter. So the parameters side is empty. So any question? So is there or are there any question before we move on? All right, seems no question. All right, so what are functions in Starknet contracts, right? So functions in Starknet contracts are the core building blocks that allows contracts to execute logic. They implement the interface definitions and define how contracts interact with external users and other contracts. So just like how you have existence of function in other programming language, where they are used to run logic and execute different sort of things. So it's the same way also function is being used in Starknet contract. Now, in Starknet contract, there are different types of function, just like how you have also different kinds of function in other programming languages. All right. So first, one of them, we have the public functions. Now, when you say functions are public, it simply means one, they are exposed to the outside world and can be called by anybody. Two, they can be called from outside the contract or within the contract. So a function inside that same contract can call it, and then a function from another contract can also call it. So those are public functions. Then when you talk of external functions, right? External functions are also public functions. So, but these ones now, these external functions, they can be directly invoked through a Starknet transaction. Then secondly, they can mutate the state of the contract. So take note of these two. This one can directly be invoked from the Starknet transaction, whereas this one, then the second thing is that it can also mutate the state of the contract. Mutate simply means change, right? It can change the state of the contract. So that's the difference between external and public. External functions are also public functions, but with more functionality. or should I say more performance in this case? No, it can't be performance. Anyways, just put it the way you want it. So then next, we now view functions. Now, these view functions, right, they are public functions also. But it's just that they are read only. They don't write to the state. They only get information from the blockchain. They don't write information, they don't edit, they don't add any information to the blockchain. They only read it. Understood? So let's look at implementing functions in Starknet contracts. All right. So the functions are implemented in an implementation block that matches the interface. So this matches the interface. We'll still come to it. What it simply means is that every single function in your interface must also be inside of your implementation. That's just what it means by this word that it says that matches the interface. So you say the block must be annotated with this thread. So take note of this: ABI embed underscore v0. So you still be taught this ABI is called, for those that are programmers already or in the Web2 space, you must have worked with APIs, right? Application Programming Interface. Well, in blockchain, right, the means by which information is being shared to the front end from the blockchain is through ABIs. So this ABI is called Application Binary Interface. No Web3. We must, everything Web2 must give our own name. So take note of that. So now, okay, this to expose the function to the outside world. So why you have to use this is, without using this, there's no way you can expose the functions to the outside world. So that's why you have to include this. So this is an example of implementation when you are implementing function, right? So it means that all these functions here, increment, decrement, and get current count, must have already been inside the interface before here. They will now be implemented here. So take note of this. I believe that you guys should be able to do something like this already. Last week, I believe you have been taught increment, decrement, how to write a Cairo program, because this is just virtually Cairo in itself. The way the function keyword, the function name, the parameter, the return type. All right. So any question from what we've done so far? Because we are about to move to the interesting part of today's lesson, which is code. So before we get to the coding aspect, is there any question or any contribution or any addition or subtraction, multiplication, division? So is there anyone you want to do?
Okay, my question is this: what did you say? You said before implementing the code to start to the interface.
Yes.
Like the condition you said it must be met. I didn't get it.
Okay. Okay, that's for this one. When I was talking about implementation of the functions.
Yes, yes.
Okay, so what I simply means, if you check here, they said functions are implemented in an implementation block that matches the interface, right? So if you remember, when we are looking at interface, right, we said that for every function you'll be using, you have to declare them inside of this your interface. Although it's not always the case. There are some functions you don't need to implement in the interface, but for function that you want to make public, you want them accessible to the outside world, right? You have to put all of them inside interface. So for instance, for this smart contract that has increase balance and get balance in its interface, when it comes to the implementation, right, it means I must implement these two functions, increase balance and get balance. So that is what this one means, that a function implemented in an implementation block that matches the interface. So all the functions that you define your interface will be what you now come and implement inside of your implementation block. And your implementation block, you start with the keyword IMPL. All right. So is there any question? All right. So time to code. So do I need to give you people 5 minutes to, for those that with their system, to get set, or I should just fire on? That's for those that want to follow along. Okay. So let's give them just 5 minutes. So by 9:55, start our code. So let me share, no, sorry, not this. So let me share what we'll be working on. So we'll just be working on a very simple counter contract, right? That's basic, not much. And you also have this assignment. So okay, let me start sharing good news for you right now. So you have an assignment here. So look at it. Take home assignment. All right. So you have to pay attention to whatsoever we'll be doing right now. Stage. Once you are programming, this is your first time doing Cairo, I would advise you to always have your documentations open. Any area you are looking at, open your documentation. You are looking for something, go ahead, search for whatsoever you are looking for and go there. You understand? So don't attempt cramming everything. So that you now start thinking that I don't know this thing is hard. No. Always open your documentation, check, read, understand what is there. If you don't understand, reach out to your fellow bootcamp mates. I'm more than sure that many of them will be willing to help you. If they can't help you, you can always talk about your challenge on the group. Any of the mentors can help you. You understand? All right. So now, I believe you guys must have installed Scab and Cairo and other tools you'll be needing. So when you want to start a project, right, the tool we use for starting either a Cairo program or Starknet contract is Scab, right? It makes everything easy. It's not that we cannot start it afresh, create file, create folder, but it's time consuming. There's no need for that. So we have a tool that can help with all that, which is Scab. So now to create a project, you just use the word Scab, new, and then the name of whatsoever thing you are working on. Now, what we want to work on is counter. That's what we are working on, a simple counter application. So I'll go ahead and then type counter. All right. So Scab new counter. Let me increase the size of the terminal more. Yeah. So once you've done this, you just press enter. Now it's going to come up with two options for you. Starknet Foundry being the default, and then Cairo test. So in this case, what we need is the Starknet Foundry, because that's the one that has the Starknet contract. All right. So we'll enter it. And then once it's successful, you see this message, created counter package. So once you see that message, you can check to be sure. You can see it has been created. And then I'll just CD into it. And once I'm inside the directory, I'll just go ahead and open it. All right. Code dot. So what this one simply means, code is the name of your VS code. That is the package name. And the executable name, that's it, code. Why this dot? I'm telling it that open VS code where I am, in the current location I am right now. So enter. So now you can see it has created SRC, the source directory, the test directory. If you enter inside this lib.cairo, it has also created, let me increase it, this thing, sorry. So I don't know, is it big enough? Are you guys comfortable with it this way, or I should still go ahead and increase it?
Yeah, it's okay.
All right.
Sir, please increase it, sir.
Okay. What of like this? Are you okay with it like this? All right. So now, once you run that command, by default, this is what it will present to you, right? Let me close this. So by default, this is what is going to present to you. Now, is what we are seeing, like what me and you guys, what we are seeing, are you familiar with it? Are you familiar with what is on line 3? Is anybody familiar with what is on line 3? Mona talk now.
Yes.
Yeah.
Good. Is anybody familiar with what is on line 12? Is anybody familiar with what is on line 4, 6, and 8? Okay. Is anybody familiar with what is on line 16? So if you look at our slide, if you compare what we have right now here and what is on our slide, you realize that we have so many things that are familiar here. All right. So now, this is a Starknet contract. Why is it a Starknet contract? This is what is making it a Starknet contract. Remember, where you add a threat, and threat of what? Starknet column contract. Now, for every Starknet contract, for all the functions you want to expose to the outside world, it has an interface. This is our interface. So you can see what I was telling you about I. Now, it's not compulsory to use this I, but just that it's more like, there's a way where there's what they call programming rules, where even if you don't follow the rules, it will still work out. But following the rule, it makes your code more readable and better for other programmers. So, so that's the essence of this I. It makes it like this an interface of Hello Starknet and all of that. So you see, the advantage of having this template is that once you want to start programming, and then you start up and you have a template like this, you don't need to go and start checking documentation. What should come first? Interface, okay, next, contract, okay, storage, okay. No, you don't need to do all those ones. All right. So here we already have this. What we just need to do is to remodify this to suit our own purpose. So let's look at what are we planning to do right now. What are we planning to do? Here's my slide. Good. So this is the task we are working on. And it says what? Task, create a counter contract, stores a counter value. That's the contract stores a counter value, increments the counter, it decrements the counter, and also retrieves the current counter. So good. Now I go know people will be ABA devs. Come here, I don't know anything. As you don't reach programming now, I go teach me today. So I'll put everything here so that you can actually be seeing what we are doing. All right. So I'll actually comment it out. Yeah. So now, okay, please go on. I can see hello vibes. Yeah.
A little bit out of the class.
Okay.
This Starknet Foundry, are we supposed to install it before it runs? Because I think my own is showing error.
Starknet Foundry.
Like to start a project.
Did you follow the installation video they sent on the group? That's before the week. Even
yeah, I did that.
And you install Scab.
Yeah, I did that. I've been running programs though, but with test runner.
Okay. You know what will happen after the class? Just chat me up.
Okay.
Yeah.
Sorry. Excuse me.
Okay.
Sir.
Okay.
I think to answer this question, you don't need Starknet Foundry.
Okay.
Until you need to test your program. So you can do it without Starknet Foundry.
Okay. So if you heard, right?
Yeah, I heard him. Thank you very much.
All right, you're welcome. So I think somebody else wants to speak. Who is that?
Okay, that's me. I want to say the same thing. I want to ask the same thing, like the Starknet from because when creating a folder, show
Yes.
our terminal.
Yes.
We have to choose when you put your scab in it, you have to choose this the package you want, whether Starknet Foundry or scab test, something like that. Something like that. So
Okay.
you normally use the scab test now. So we don't
Yes.
normally use this
Okay.
Starknet Foundry. So that one I want to ask too.
Okay.
About,
Okay. No, this one you can just use your scab.
okay.
Yeah. Yeah. All right. So back to our program. I need 1, 2, 3, 4. Good. I need 4 people, 2 ladies, 2 guys. So starting with this one, what do you think this one is? Remember, we said when we are talking about contract class, we mentioned 3 things, if I'm not mistaken. All right. We said what? Who can remind us?
Storage.
Good. Storage.
Then I think the entry points. Yeah.
All right. I love this. And then
Then
finally,
the events that are emitted, or yes.
okay, good. Now, I want us to point each of these. For this first one, who can help us? Which category does this first one falls under?
Under the struct.
That is storage.
Under the struct, the courage struct.
Beautiful. Now, for this second one, which category does it falls under?
That's the entry point.
I love this. What of the next one?
Same thing. Same entry point.
That's so good. There is bath. I must use and bath this night. The last one.
Event.
Entry.
Okay, entry points.
Beautiful. So if you remember, right, when we were looking at the difference between Cairo and normal Cairo programs and Starknet contracts, we said Starknet contracts have more than one entry point, several entry points, but Cairo program only has the main entry points, right? So now looking at what we have here, this one is automatically the storage. Why these 3 are the entry points? So another question, where does the entry point goes to?
Sorry, sir. You have to come again. I don't understand that question.
Okay. Now
it goes into the module, the mods part.
Okay. Beautiful. Now, we made mention of 3 important things: storage, entry point, and then events. Of course, we don't have events here, right? So now you people still do events. I know us scatter on our head too much. More do a thing day for today, and even God say more pray for daily bread. More no think of waiting they come tomorrow, right? All right. So now we've looked at it that okay, this one belongs to the storage, why these 3 belongs to the entry point. Now, if you remember, when we were treating class Starknet contract, right, we said the entry points are all functions, and if there are functions that we want to expose outside, that's functions where we want people to have access to it and interact. And from what we have here, it looks, looking at these 3 functions, they are functions that other people would be able to interact with, because before you can increase the counter, somebody will need to come and increase it with a particular number. To decrease it, somebody needs to decrease it. And then to get back the current value of the counter, we also need somebody to do it. So it means we have to expose all these 3 functions. And for that, we say that to be able to expose any function, to be able to, for those functions to be accessed externally, we need to bring them inside our threads first. So it means that I'll just comment this out, right? So it means that we have to bring in increment, decrement, and then retrieves. So now, okay, let's go on. Of course, we need our function keyword, which is fn. The name of the function is what? The first one is increment, right? So it depends on how you want to name it. You can name it increase count, you can name it increment, anything is your choice, right? So I'm going to name it increment, right? Now, this increment, before we even come here, sorry. Now, back to this place. You know, we are just using the template that was generated. All right. This one says, hi, hello, Starknet. And the contract you are writing is a contract that will count. So instead of using hi, hello, Starknet, we can use hi, counter. You can use any name, it mustn't be counter. But we want the name to match with what we are doing. So we name it I counter. All right. And then also our module here, that's the Starknet contract itself. We also name it counter. So now I counter, and then you can see that counter is having a T contract state. So remember when we talked about that Starknet contract are stateful. That's you can actually write to memory and also read from memory. So that is what we are actually attaching to this. We are attaching that particular contract state so that at any point in time, we'll be able to access the state of the contract. Right? And then somebody will say, what about this T? What does it mean? It simply means type. For maybe those of you that have coded in Rust before, if you are bringing in a custom type, you have to indicate it using this form. But that's how far we'll just go, the explanation. So now, for increment, now, before we'll be able to increase a count, it means if you are increasing something, it means you are changing the state of that thing. It means if a number is 10, I want to increase it by 2. So I'll say 10 plus 2, 12. It means I'm changing the state from 10 to 2. So in that case, since I'm changing the state, I have to bring in my ref and then self. And then what am I assessing? Remember, I attach this T contrast state to this my thread. So to be able to access this state, the state of the contract, I have to make this self to be a type of this contrast state that will be assessing. So I'll come and put T contract state. Now, why am I using ref? It's simple. It's because I'll be making changes to this contrast state. Increment as a function is a function that will make changes to the contract state. So that is why it has to be referenced. You know, I believe they taught you guys reference when you are borrowing, you are referencing, you are not something like that. So now increment, I will need to add a number to it. It means I need a variable that is a number. All right. So in that case, I can now come and say, okay, the number I'm increasing with. Now they taught you guys data type. So I feel I should use U32. I don't think the number will be adding. I don't think it should be more than U32. All right. So now the return type will now depend on you, what you want. Do you want it in that once you increment, it should send that it has incremented successfully? That's in that case, you can use bool to tell you true or false. True in a situation where it's successful, false in a situation where it's not successful. And if you like, you can decide that no, I just want it to increment. I don't want it to send anything. And that's where events will come in. So your event will help you to know whether it has actually incremented or not. But just like I said, event is not part of the scope of this class. In our next class, we'll look at event. So for now, I'll just make it to return a Boolean. That's true in a situation where interruption. Yeah, I'm so sorry for that. So why I'm using this ref self is because I'm going to change the state of the contract by reducing whatsoever is in the counter. And when you hear change state of contract, put it at the back of your mind that is you are changing whatsoever is sitting inside of the memory of the contract. That is simply because by the time we have counter inside our memory, if we are incrementing, increment will change the amount in the counter. If we are decrementing, decrement will change the amount in the counter, right? So this one, so I want it to return bool. That's in a situation where it's successful. True. If it's not successful, false. And then the final function, entry function here, is the what? To retrieve current count. So this one, I'm just going to name it current, or instead current, or just say get count. Now for this get count, I'm not changing anything. I just want to read the value inside the memory. I just want to peep. It's not as if I want to do anything. So in that case, I don't need this ref. And also for this T contract state, right? I just need a snapshot of it. They call it snapshot. I believe you guys were taught last week. I just need a snapshot of it, right? That's why you see this at. I don't even need this number because I'm not changing it. This one, of course, I want to get the value inside the counter. So, and from here, this should give you an idea of what's my counter, the data type of my counter. It should be a U32. They taught you guys data types. All right. So I'm expecting it to return a U32. So you can see that in our threads, we now have increment, decrement, and get count. Now, the next thing is we will now come to our contract side. Of course, we have changed the name of this one to counter, right? This one, you need to always import it. Why? Because this is what will help you to be able to write to storage. This one will help you read to storage, and this one will help you write to storage. Storage pointer read access, storage pointer write access. So always and all they are gotten from the storage, which is from the core Starknet. So this use, they have taught you guys how to use to import. I'm sure of that. So now storage, what do we want to store? So somebody should help us. What should be inside this storage? Sharp, 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 sharp. Don't worry. Don't just talk.
It counts.
Good. So the count should be here in our storage. So we have count, and count will be in what data type?
U32.
Beautiful. So U32. So are we getting it? Okay. So now we have our storage. The next thing is to now come and implement all our threads, which is the increment, the decrement, and the get count. So we'll come here. You remember our slide where we talk about ABI embed? When you want to implement your function, right? You attach the threads, this ABI embed. All right. So now what are we implementing? You know, here, what we have here is our counter, right? So we're actually implementing the counter. So we have counter, implement, super. I believe they taught you guys how to import using super and all of that. I'll not go to that. Now we are implementing the threads here, and the threads we have here is no longer the other one. We renamed it to be I counter. So we are implementing the threads I counter. So when you use super, right, using super is as you can see, this place, this thread is outside of this module. So to import anything outside of your module, you use the word super. Once you use the word super, you'll be able to access whatsoever thing is outside of the module you are working in. So super, and then we're able to import this, our threads here, which is what you are seeing here. So we are implementing counter contract for this, our threads. Now, who can help us? Why do you think this thing is throwing this error? Why is it throwing error? Why no allows land? You never allows land. It's just they holla. So why they holla?
Maybe because there's no interface.
Beautiful. I love that. I love that. All right. So if you look at it, if you remember what, like in our last part of this slide where we're talking about interface, right? We say it enforces implementation. So what it simply means that every function, every single function in your interface must be in your implementation. And right now, we don't even have any of the functions in our interface in our implementation, right? So it means I have to clear these ones out and then start my implementation. So the first one is what? Is increment. All right. So we have fn increment, and the increment, we say we are taking ref of self, and then self we say is what? Contract state, and then we are taking number. I will say number is U32.
Sorry to
Okay.
interrupt. My own did not throw error. My increase balance and my get balance was still here, but it wasn't telling me, there was no error message to know that there was no interface.
Okay, it seems maybe, but did you install the plugin, the Cairo 1.0?
Yes, I have Cairo 1.0. Is there anything else you're using?
No, nothing else. But don't worry. After the class, let's see what we can. Yeah.
Thank you.
You're welcome. So now we are returning bool. Mind you, it's not compulsory to return bool. So that in case you are doing your own program, is based on what you want, right? So now we'll be implementing the function value of this. So looking at what we have now, what do you think this function should do? So somebody should help us. What do you think the function should do?
Okay, the function should increase the count, which is the storage, the structure storage. It should increase it by 1.
Okay.
By the number, sorry.
By the number. Beautiful. So now it means that before we even increase the count, right, we need to assess the count, isn't it? So of course we can use let count, you can use count or current count or anything you want. Now in assessing this count, remember it's being stored in the contract state, so we have to assess it via this self, right? So to assess it now, we'll say self dot. Now we'll check what is inside the storage of this contract state. What is inside here? Inside this storage, what is it?
It's count. It's variable count.
Count, good. So we have self dot count dot. Of course, what we are interested in is not just count, but the value of count, because this count is just the name. This is the value. So we now say dot read. So what we have done here is to read the value of our count. Why is this one true? Okay, I think the error is yeah, okay, it's normal. It's a normal error. Right. So like, are we on the just like I say, your contract state is a representation of your storage, your contract storage. And then to be able to access what is in that storage, because before we can even add, we need to first know what is inside before we now be able to add what is inside, add the number to whatsoever is inside there. So to access it, already this is the storage state of the contract. So we pick it, which is self. Then to be able to access what is in the storage, we want to access count, because you can have more than one thing inside your storage. You can have count, you can have other things. So now to be able to access that particular one, we now put dot, the name of it. In this case, the name is count. Then dot read. So once you do this, the value of your count will now be stored inside of this variable. Now let me ask a question. As it is here now,
I have a question here. There's something I don't understand.
Okay.
Yes, the structure, when we have a structure, usually it is the dot notation. So we usually address whatever is inside the structure as storage.count. So I don't see you doing that here.
Beautiful. Now, if you get my explanation, what I just explained right now, right? I say this contract state is a representation of the memory of the smart contract. Now you have, this is a designation of the memory of the contract, the storage of the contract. So I don't still need to come and say self.storage before I'll be able to access count. By just accessing the state, I've automatically have access to whatsoever is in the storage. Do you get?
Okay, I get it. Thank you.
This is actually how Cairo contract is being structured. You understand? So now my question, right?
Yes, sure.
Now my question is, as this count is here, can we actually make changes to this count the way it is like this? Sharp, somebody should answer. Look at your time. Like we are even spending more than the time we're supposed to spend.
I didn't get it. Is it going to be mutable?
Beautiful. So for we to be able to make changes to that count, it has to be mutable. So I have to say, let mute count. So now once we read the value, it means whatsoever is in the storage right now, it's going to be stored inside here, right? So now I can now come and say count now. How should we even do it? Okay, let's say let new count be equal to count plus what? This is the number we are adding to it. Number. This thing just. So do we understand what is going on here? What is happening here? We have to increase this count by this number. We use this to get the count. That's the existing count here. And then after getting the existing count, we now create another variable called new count. And then we now added the number to the initial count that was there. And then store it inside the variable new count. So now we have successfully gotten the new count now. The next thing is to write
question
back to storage. Okay, please ask
is it necessary to create a new variable to increase the new count?
No, it's not.
Well,
it's not
since
necessary.
It is mutable, isn't it possible to just reuse it?
Okay. It depends on how you want to do it. It's not actually necessary to use what is here, but I just want to take everything step by step. Since I don't know, I know some of you are quite good in programming, while others are still coming up. So I just want it to be relatable to everybody. Understand?
Okay, no problem. Thank you.
Yeah, you're welcome. All right. So now, who can tell me what next do we need to do? What is the final? Because we have increased the count already. So what is the next thing we need to do?
I believe we are to.
Yeah, we need to return the Boolean value.
Are you sure? Look at it very well.
We can write to the count variable now.
Okay.
But in this case, I don't see the use of the mute anymore since we are not modifying count.
Modifying. Beautiful. You are right. Okay. So I love that. So now we need to write back to the storage, because what we just did here is to read from the storage. What we did here is to count, to increase the count, right? So now we need to write to the storage, and to write to the storage, we use our self dot. Now this time around, we use, self dot. We target the variable in the storage, which in this case is count. Right? Dot. Now, when we are to get the reading, we use read, right? So in this case now, we are writing to it, so we use write. And what are we writing? And what are we writing? We are writing what? New what? Count. Right. Now, this one is returning, is still throwing error. Look at why? Because what is expecting is a Boolean, isn't it? So next, because since here we have successfully write back to the memory, we can just return true. Please, can somebody mute their mic? Who's this person? Please mute your mic. Okay. All right. So now we return true because why? Is expecting a boolean. If there was no boolean, then we'll just leave it the way it is, but it's expecting a boolean. Now I want to ask a question. Why are we still having this? Why is this thing still showing error? Like quickly. No, our time is fast spent, so that we'll go and rest. So why is this thing still giving us this red line?
Because we have not implemented all of the interfaces functions.
Beautiful. I love this class. So for that guy that was asking that is it necessary to create this? Actually, it's not necessary. Another way we can do this as it is here, right? We can just decide to say self dot count dot right, isn't it? Write what? Self dot count dot read, right? Plus number, and then return true. Or simply instead of return true, we just put true. So can you understand now what we have here, what we have on line 41, and with respect to what we have on line 35 to 39? Can you guys relate now to it? We are getting the count from the storage, we are adding our number to it, and then we are now rewriting it back to the count in the storage. So either you go this way or you go this way. So I just decided to go this way so that at least those that, okay, they are not really strong with Cairo can have a hang of what is going on. All right. So either you go this way or you go this way. So what is the next function we need to implement?
Decrement. Decrement.
Decrement. Good. So we have fn decrement. So in fact, we'll be fast for this one. And then we'll have, let me even copy. Sorry, let me just copy this one. And then I'll just change this one to decrement. Good. So I think it's the same the same this and this. All right. So this one too, the same thing. Count, we get the count, and then new count. Of course, you are subtracting it, but we need to be careful. Now, why do we need to be careful? What if we subtract?
We might run into a negative number, so we need to do a check.
You understand? Good. I love that. So in this case now, let me just take this one off. Mind me. Let's use this one first. So now, after reading this, and then we first need to do a check. Now that check, it depends on how you want to do your own check. No particular check is the most correct one. You can decide to, is after this, you will now do a check, or you can decide to, before doing this, you do a check. So let me do before. So before, I can decide to check that if number, right? You guys will still learn error handling. If number is greater than count, what should happen? Should we return false, or what should we do? How do you guys advise we handle this kind of error now?
Just set the count to 0.
Okay. So return, let's just put false. Okay, see this one. You want us to return by false. So return false. All right. So technically, just like I said, you can decide to do the check either before or after. Now, if you are doing before, this should be it. If you are doing the check after, that means here you will now have to check that if new count is less than 0, right? Then you should now return false. So either of these.
Sorry.
Okay.
Excuse me.
Okay.
If the new count is less than 0, it will throw an error.
An error.
Yes, because it's an unsigned integer.
Unsigned integer, exactly.
So the thing we are going to just use that first check.
That first one. Okay, good. So you can see, thank you for pointing that out. You can see for the data types, you unsigned integer, you can't on unsigned integer, you have from 0 upward. You don't have any negative value. I didn't mean we make use of, let's say, a signed integer, and I don't even think signed integer exists in Cairo. It's not even supposed to. So we just have to do away with this and then focus on this. Once this number is greater than count, it simply means if you minus them, you definitely have a negative number. So from here, you should even say it's not possible. So in a situation where the number is not greater than, it means it will continue and then go ahead and then subtract. So after subtracting, then it will write whatever it has now back to the memory and then return true, telling us that, okay, it's actually successful. So doing that here is the same thing with these two. After you must have done your check, then you can just come and do this. In this case, instead of plus here, you'll be having minus. So that will just be the difference. But this your check will remain intact. All right. The only thing that is changing is, okay, for this one safe, just do it this way. Because you need to get this value first before you can perform your check here. And if you are getting the value here already and performing check here, there's no need of coming to reread a value again. It's more like you are doing two work at the same time. Where do we have? Okay, so let's quickly finish it up. Then the final one, get count. We hope. All right. Okay. So the last one now, get count. Now in our get count, we have fn get count, and then we are having our self, right? And then self is having a snapshot of the T contract. Is it contract class or contract state? Sorry, states, and then of course that's the only thing is having T contract state. Yes, and then it's returning the value for us U32. What is wrong here? Why is this thing throwing an error? Okay. Contract state, sorry, not T contract state. So for this one now, we have to get the value and return it. So here, to get the value from our storage, of course, the variable here is count. So we are going to have, okay, let's say let count be equal to self dot count dot, of course, read. So then we can now decide to return count. So there are different ways of returning count, of return statements. Either you return just count like this, or you go ahead and then use your return keyword and semicolon. But I think this one is more elegant. So I'll leave it this way. So now coming back to this, you can see that we no longer have this counter implementation throwing an error. Why? Because of we now have fulfilled all the promises of our interface. The three functions in our interface are the three functions we implemented here. So take note of that. So are there any questions before call it a day? Any question?
Please, sir. Can we have a sort of maybe a code base of this code later on, because for those that are not coding alongside?
Yes. I'll definitely push it to my GitHub repo, and then I'll share the link with you guys.
So
all right.
Sam, how do we run the program? How do we
Okay,
run it?
yes. Okay, we are running it now. So
Okay.
let me just let me clear all these ones that are not useful. Then there's one other thing. Okay, this one is useful actually. There's one other thing, although it's not always necessary, but is important. Constructor. I did not know why it was not mentioned. Yeah, supposed to mention it. So constructor function. So your constructor function, for those that know programming, in JavaScript there's constructor function. I think even in Python you have init. In Java, I don't know what is being called. Yeah. So your constructor function is more like the first function that runs just once. Once you are uploading your smart contract, right? It runs once. So you can use that function to set up your initial values and all of that. So I did not do it here, but we can use our constructor function. You just have to add it here. So constructor, yes. Then constructor function, and then we have fn, right? So sorry, yeah, fn constructor. And then of course the constructor function, just like we said, it will help you set up your initial values on your storage. So that's why we have to take the reference of our memory, and then we have contract state. And then of course, since here the only parameter we have here is our count, we want to set an initial count. Let's say initial count of 0. So we can bring in maybe number, or even the count itself, does not matter. And number, and then U32. So now we'll just set the initial value of this. So we have self dot. Now the storage, to access it, this is what we access inside our storage, count. So we have count dot, right? Now remember, we want to set the initial, so we actually write into it, and then want to set it to the value of 0. So this is, just like I said, it's not always necessary, but it's important in a situation where you want to set an initial value for whatsoever you are doing. And why this one is the best to use is because it runs only once. It runs when you deploy it. So once it runs, it sets this one as initial value of 0. Any other thing you are doing, this one is no longer affecting it. So take note of this. So are there any questions? Time is fast spent already. Any question?
Question. I would have thought that these values would be initialized by default to their default values.
Not really. Yeah, not really.
Sorry.
Okay. So you explicitly have to do them.
Yes.
No.
Yes.
Wait. I think
Okay.
Lamin is right. The storage you initialize count as 0.
Yes.
But why you might need a constructor is you're right too, because that's number in the constructor parameter. You can actually put that self.count right, then remove that 0 and put the
that's
number.
0. Okay.
Yes.
I even forgot that. I forgot that I put number here. So you can initialize it with sorry. Self dot, so number. I don't know that that's what you were asking. But you can also put it that it should start from 0, since by default number starts counting from 0. But you can decide to set it to start at a particular number instead of starting at 0. Yeah. Right. So any question apart from what you've asked? Any other person? All right. So the person that was talking about testing, the way we can test this is to see if it will build. Another way is to declare and deploy, which of course is not part of this class. The another way is to test, which is not part of this class. So the one that is part of this class, we'll just run it. We can use scab run, the scab build. Okay, scab run is not going. I mean Cairo run. So let's use scab build. So this should run. Okay. So it's successful. So since it's a successful, we'll assume that it's working. But the more proper way is to declare and deploy, or you test it by writing tests. But just like I say, it's not the scope of those two, are beyond the scope of this class. So that's why we will not do that. So once you are done writing, you just do your scab build. And if it works successfully, it means everything is intact and in line. So any other question? Okay.
Sir,
Okay.
excuse me. Please,
Okay.
what's the difference between scab run and scab build?
Okay, actually, I don't think scab run is running. Sorry, I was looking at it from the perspective of cargo run in Rust. Because cargo run, what it does is that it builds the program and then run it. But in this case, since scab cannot run it, so I think that's why you don't have anything like scab run. So scab run doesn't work. So it's scab build actually to build it.
Okay.
But in Cairo, in Rust, sorry, you have cargo run, which builds and then run the program, or just cargo build, which you just builds it and leave it for you to decide whether you want to run it or not.
Okay.
Yeah. So any other question? Okay. So thank you for today's class. You have an assignment, which is this. Of course, they will share the slide with you. So this is the assignment. So it's nothing different from what we did, but this time around, you'll be dealing with storing name and age of students, also updating, finding a means to be able to update those names and age. And then also you find a means to be able to retrieve those name and age. So you are free to use whatsoever kind of way or method, whether you want to employ struct or not. It all depends on you. Yeah. Okay, go on, praise.
Please, I'm sorry. Go back.
Okay.
Go back to your code. The code.
All right.
Let me zoom in.
Which place in
line? Yeah, in line. In the struct you created.
This one?
Yeah, the struct you created now.
Okay.
Okay.
Is it this one?
Like the struct.
Okay, this one.
Yes. No. So now, okay. You said we were trying to decrease and increase, and you created the function that says the number plus count.
Yes.
The function. Yeah, I'm sorry, count plus number, and
Number,
also
yes.
count minus number. So
Number, yes.
you only in the struct the count you only declare the type of data, but you didn't assign any value to it.
Yes. You know, if
also
you
the number here as well. Even the constructor number. So you just say number. You declare the type of data, but there's no number assigned to it.
Okay. So this one, right? Parameters. When a function has parameter, it means the function is expecting an input from you.
Okay. Yes.
So for this constructor, once you are running the program, it will require you to give an input of a number.
Okay.
So it's until when you give that input that it will now go ahead and execute it.
Okay.
You understand?
Yes, understand.
So that is what is happening. Then in struct, struct is a data type.
Yes.
It's a data type that houses other simpler data types. So once you are declaring anything inside a struct, you only declare the name of that thing and also the data type.
Yes, it's true. I remember now.
Right?
I remember. Yeah. Okay. So another question, please. So
okay.
Like which other this now really I'll use like for instance this constructor now.
Yeah.
So this is like a parameter.
Yes.
Parameter now that like a placeholder that should be holding the number that will be imputed in it.
Yes.
So where are we supposed to to call that number?
That's what I'm saying. Once you deploy, you do it in week 4 or 5. I can't remember right now. So once you deploy this smart contract,
yes,
you understand, there will be
yes.
a place where it will show you where you have to impute this number for the smart contract to be able to run.
Okay, okay, okay.
You understand?
Yes, I understand now. Understand. Okay,
All
thank you
right,
very
so
much.
you're welcome. So for those that have questions, please, we'll do it next time we meet. That's in 2 days' time. All right. So thank you, everybody, and have a nice day. I'm sorry for taking your time. Yeah. Sorry for taking your time. So thank you so much. I don't want to say I love you guys. Yeah, but I actually love you guys. You did well.